So now let's do machine learning in Python, and for that we'll use the scikit-learn package. And before we jump into the actual code, we'll quickly go through the structure of scikit-learn. And at the center of this package are its models. So scikit-learn, or also sklearn, offers us different machine learning models. And so the first step is to import this model class, so that in the second step we can then from this class initialize a model, and these hyperparameters affect how the model learns from the data. And then in the third step, depending on whether we're doing supervised or unsupervised learning, we split our data into targets and features. So that then for the supervised learning task, our model can get the features and then from it predict the targets. To be clear about why it's called supervised learning, this is because we cannot just use any data, but we need labels or targets. So for example, a label saying cat or dog. And so we can say the data has to be supervised by us or someone that can provide these labels. And so essentially we're supervising the model, giving it feedback on whether it predicted a label correctly or wrong. And so after we splitted our data into feature and target, we can then train, learn, or fit our model on the data. And in scikit-learn, this is usually done by calling the .fit method on our model. And once our model is then trained, we can then for supervised learning call the predict method, and with that predict the labels for unknown data. So you can imagine our model sees now a new image and will tell us whether that's a cat or a dog. For unsupervised learning, we can also use predict, but also transform. And so you can imagine here that we use our model to transform a 100 dimension. And so you can imagine that with this transform, we transform data that has 100 dimensions to data that has now 2 dimensions. Okay, now let's start with supervised learning. And if you remember, supervised learning was divided into classification and regression. And we will start with regression, more specifically linear regression. And so in the first step, we import from sklearn or scikit-learn.linear model the class linear regression. And then from this class, we initialize our model and we pass the argument intercept equals true. And we will see in a second how that influences our model. And then in the third step, we split our data in a feature matrix and target vector. We say matrix and vector because usually we have a lot of features. So for example, a data point with 100 values, and then from it we predict a single value. And so because we have multiple data points with multiple values, we have a 2D matrix. But for every data point, we have only one target, and so that makes a vector. And in our example, we are creating some toy data. So our input are just some values from 0 to 10, and then the y values are generated using a linear function plus some added noise. And now in the fourth step, we call on the model the .fit and pass our features and targets. And this will then fit our model on our data. And after our model is fitted, it has learned some parameters that help it model our data. And so the name linear regression already suggests what kind of model we're dealing with. And that is a simple linear function. And so all a linear function needs is a coefficient and an intercept. While we will always have a coefficient, the intercept is not strictly needed. And we can even tell our model to not adjust the intercept. So that's what the fit intercept was for. But in our case, we now have a slope or coefficient and an intercept. And so if we apply our model to some new data using the model to predict, that will give us this line here. And so a real world application for this model here would be, for example, to predict how some price develops over time. So we have all our data points here in blue, and with these data points we learn a linear function that will tell us then exactly how much the price increases per year. Note however that sometimes the values can be a bit misleading, because of course the price should never be negative, for example. So keep that in mind. Next up we have a classification example, and here we'll use decision trees. So first step, we import from sklearn.tree the decision tree classifier class, and then with that we initialize our model. And then again we have some data. Here we're loading the iris data from the sklearn datasets, and we can have a quick look. So x is our feature matrix, so every data point has 4 values, and then our y are the corresponding targets to these data points. So then we call model.fit on the data, and then we could apply this model to new data, but the decision tree also serves a different purpose, because it helps us explain our data. So what the decision tree learns is how to decide which class a data point belongs to based on its features. And so every one of these nodes, which is not a leaf, corresponds to a decision. And we can see this decision in the first line here. So x is here our data point, and if the third value of the data point is smaller or equal to 2.45, then we end up in this node here. If it's bigger, then we go to here. The second value in the nodes is the Gini value, and that is not really important for us, but it's used for internal optimization. The third value samples, tells us how many data points we have at that current node. So in the beginning, all of the data points land here, but then 33.3% go into this node and the rest goes into here. And so then the last line tells us what the model thinks about the classes of these samples. So we have here 3 values for 3 classes, and the model thinks that at this point they're equally distributed. And then, for example, after making this decision here, we see that we have here a 1 and then 0, 0. So the model is confident that all the data points that end up in here are of the first class. And so this helps us now understand our data, because what the tree tells us is that the data points that have as a third feature a value smaller or equal to 2.45, and this could be, for example, the height of the flower, and if the height is smaller or equal to that, then the flower is of the first class. And so these decisions are made at every node until we reach the maximum depth of our tree. So this is also something that we could change. But in general, we don't want our trees to be that deep, because then they will not be that explainable anymore. And now, of course, we can also use these decisions to predict the label for new data points. And for that, we call the model.predict. And here we're passing some old data, but of course it also works for new data. And we can check that the prediction, at least for the data that it has seen before, is correct.